Okay, so today we're going to see our first session on the technical part. It's going to be about spec-driven development and MCP. So I'm sure you have been exploring a lot about it while you were working on week 0 assessment, but we have to see and know the foundational truth of what spec-driven development is and MCP is, since we're going to use it for the next couple of projects. So I'll share my screen on that and we'll explore what it is. So can you see my screen? Okay. So before we go deep dive into the spec-driven development, we have to look at the evolution of development. Remember that we're talking about development in AI era, so things have changed. Whatever we're working with is using AI. But there was a time where we had not got the chance to work with the AI. So let's see how it evolves, how the development evolved to this stage now. So we'll start from that. So so let's see the evolution of development. So and on the first part was the test-driven development, which the code was the truth. We use the code as the truth. Then it got evolved into the behavior is the truth part. So behavior becomes the truth. And then we move to the spec-driven development, which is the intent is the truth. What we are going to discuss right now is the spec-driven development in the AI era. So this is going to be our core parts while we are talking about the spec-driven development. So now we are on the spec-driven development. Let's see why we need the spec-driven development. Since we are talking about the AI, we know that the LLMs are so powerful. They work based and they have the accuracy and they are efficient enough to give us what we ask them. But without any structure, they may drift or they hallucinate or they may over-engineer things. Since we're talking about engineering, we don't have to forget about the architectures and the principles of engineering. So how are we going to align these two things together? So this is going to be the spec-driven development will answer the gap, which is created by the LLMs. They're powerful, but they are not in, they don't have that capability of what the engineering needs. They are probabilistic, but the engineering needs or it requires determinism. So in order to fill that gap, we use the spec-driven development. So it comes to this gap. So without any spec-driven development, the prompts we use or the things we give to the LLMs, it's a inconsistent and it's variable. So we need the spec-driven development because of this issue. So from now onwards, we are going to use this spec-driven development methodology while working on software engineering or software development in the AI era. So let's continue. Let's see the workflow, how it looks like. The workflow looks like So when we are saying spec-driven development, we are saying that there is going to be a specification to be followed. So in order to do that, we will specify what is actually need to be done. The specification actually tells us what the user is actually needs to do. The user story, it tells us what needs to be defined, what needs to be done. So the specification part is the one that defines what's going to be done. Without this specification, we're not going to continue to the next parts of the flow. So then, based on the specifications we have put, we'll plan using the specification part. So the plan shows us how those things are going to be done. So it will answer the question how it's going to be done, how it's going to be the architecture, how it looks like, how it's going to be put. So all these things are going to be put on the plan section of the workflow. Then based on the plan, there will be tasks. So the tasks are the ones we get from the plan. Those are the units, the atomic units that are going to be implemented, which is the last process, which the agents write the code. So from now onwards, the agents are the ones which are going to write the code, but we are not going to be based on any other source, but the source of truth is going to be the intent, as we have said. So that intent is going to be defined on the specification. So in order to do all these things, we have to give priorly we have to constitutionalize things. Since there needs to be a boundary, there needs to be a confined environment to get what we actually want to achieve. So the real intent will be implemented based on these things. So that's why we use the constitution and all this specification, plan, task, and implement. So based on that, we are going to achieve what the engineering actually needs using the AIs. So what is constitution? So let's see what constitution gives us. So it will constrain the behavior of what we are going to do. It constrains the behavioral part of what we're going to do. It takes us a higher part of the rule book. So it governs the agent, how it behaves, how it actually needs to behave. So this is the one that controls the behavior, not the feature, but the behavior of the agents. And why does it matter? What if we don't have the constitution? Then the agents may over-engineer things, they may hallucinate, they may violate design principles. So we are not going to get what we actually want to get at the end of the day. So this constitution is important enough to give us to achieve what our intent. So in that part of the constitution, what we are going to define is the tone, what it actually looks like, the architectural constraints, how it's going to be confined, in what architectural pattern it needs to be put. So all these things and the design philosophy are going to be put on the constitution part of the spec-driven development, so that it's going to be flowed into the workflow. So the next one is the specification. So this is the intent of what we're going to work on, the source of truth. This is the source of truth. This is what the system is going to work on. So it includes the user stories, the functional requirements, and the acceptance criteria, and the edge cases. These are actually put on the spec file. And while working on the spec, what are going to be avoided? We are not going to talk about the tech stack decisions there, the framework decisions there, the implementation details. These are not going to be mentioned on the specification part, since we are not going to implement on the specification part. The specification part will not include these things. So it's because of this, it only focuses on the outcomes, what actually has to be done. So it avoids the premature implementation biases, and it makes requirement reusable across stacks. So on the specification part, we just tell the intent. And the next one is the plan. So the plan is the strategy. So how are we going to implement what has been specified on the specification part? This is going to be answered on the plan section. So the plan is going to be the strategy. So how it's going to be implemented, how it's going to be achieved will be answered on the plan section. So in that part of in that part, we will have implementation, how we will have task next, we have task based on the plans, but those the plans will have the logical structure for how it's going to be implemented in. But the one thing that we have to make sure is that these plans are not just how are we going to do, they need to refer to the spec. They come from the spec. The specs are the one that defines what's going to be done. So it's not just an imagination we are going to have. So the how is going to be managed as well. So if the specification changes, then the plan also will be changed as well. So the plans will come from the specification we have put earlier. And because of this, implementation becomes, because of plan, if we don't plan, implementation will be reactive. And architecture, another concept on the architecture may happen, or coupling may increase. So these things will be without plan. These things may occur without plan. So the plan defines the strategy. That's why we say the plan defines strategy. So we need the plan as well. So based on the plan we have, we're going to have the tasks. These are the atomic units, which is the small units, that those that are going to be implemented, testable ones, clear output. These are the tasks that are going to come from the plan we have already put. So this is the workflow. If we don't have this, it's not going to give us the intention that we want. So we will follow this spec-driven development for the next couple of projects that we are going to work. So because of this, tasks are going to be measurable, and they define execution units, and we can also prevent scope creep. So the tasks come from plan. So whatever the case is, if there's no anything on the plan, there will not be a task. So whatever the case is, there's no any specification for the plan is not going to be executed. So everything works on this workflow. So the next one is the implementation. So this is the byproduct, the code. The agents are the ones who are going to write the code based on what we have already discussed earlier. This is going to be the implementation. So things are already done, the architecture is already defined, the requirements are already put on the plan, so on the specification. So things are already structured, well structured, and they are specification wise, they are well structured ones. So based on that, it's going to be implemented using this one. So the code is, we say the code is output of the pipeline, not the starting point anymore. So the intent is going to be the truth. So this is going to be how the spec-driven development will work. So in order to see how it looks like, let's just see one example of that one. So let's see one constitution. Since we have been working on this earlier on week 0, I think most of us know how to initialize the git spec kit. We use git spec kit. So we actually first initiate the project with git spec kit. So it's already done. So let's show you how the spec is the constitution of the following project. So the intent of this project is to build a task manager application. So we'll see deep into all the sections and how it's going to be implemented. So the first thing that, as we have said, is that what matters most, how we are going to control the behavior, is using the constitution. So let's see how the constitution is going to control the behavior of the agent here. We are having the first thing is spec-driven development. We are saying constitutionalizing it. So we say spec-driven development must be kept. So this specification needs to be achieved first. So these are the rules. All the implementation types must be inferred from the Zor schema, which we are going to see next. So based on this spec-driven development criteria is going to be the next part of the project will continue. So then we'll have the clean architecture. We'll use a clean architecture to work on the application we want. So the architecture looks like this. The clean architecture looks like what we have here. There will be strict separation of concern. So this is one principle that needs to be kept while working on the task management application. Then we'll have the stack, the technology stack we are going to use. The front-end end state is going to be managed by the following rules. The framework, styling, state management is going to be managed based on the following rules. And the backend invalidation is going to be managed using the API invalidation on the Next.js and Zod, as I have mentioned earlier. Zod in TypeScript is going to be used. On the development workflow, we are going to use the following rules in order to achieve the development. So the code quality is going to be achieved based on the following rules as well. So this is the constitution that we're going to use. This is the boundary. So it will work based on this boundary, not out of this boundary. So based on this constitution, we're going to have the next specification, which what we actually want to do. So we'll see how that's going to come into our task management application. So the first one, as you can see, is the first user story. It's creating a task. So in this scenario, as a user, what we want is to create a new task with the following parts. There's going to be a title and a description and status and priority. So this is going to be one of the first functional requirements that we're going to achieve. So why is this priority essential? Then adding the data to the system is that the app is empty. So we will put all the use case scenarios based on the constitution we have mentioned earlier. So we have got the create task, we have got the view task story, we have got the update and delete task story. So we have got these four, the basic CRUD application, the basic CRUD operations on the application task management application. So based on that, we have created these functional requirements. So this is going to be the intent or the source of truth that we're going to use for the next couple of processes we are going to continue working on. So based on this specification, we are going to have a plan. We'll go to the strategy, how it's going to be implemented. How are we going to work on this task management application? How it's going to be implemented? What is the language? What are we going to use? The technical contents and the context in the constitution check documentation, and all this strategy is going to be put on the plan. So this plan is going to show us how it's going to be implemented. So as you can see on the technical context, we are going to have the language TypeScript. So while working on this project, we are going to implement using TypeScript. Then primary dependency, we use this Next.js. The storage, testing, project type, and constraints are also mentioned here. Then the other thing that also needs to be considered was the constitution check. So the constitution, we want to check on the constituencies. Is that going to follow the clean architecture or not? This is going to be kept as well. So we have to have these rules need to be kept as well. So this is also important one. Then the project structure, we want the project structure to look like this as well. And based on this plan, we are going to have tasks to be implemented on the next part. So we are going to have the following tasks are going to be um, implemented using the plan we have already mentioned. So here are the plans that are coming out from the tasks we have mentioned earlier. So the first task is going to be the create a task, as we have seen. So in order to do that, we have the following uh, structure on the tasks. We set up first the project initialization is going to be put, and then there's the foundational blocking prerequisite we do have. So the first thing is the spec that must be complete before any of these are can be implemented. We need to have the spec, the schema. So we will have that one as well. And uh, after that, we are going to create the task. In order to create the task, we will have uh, these cases. So the first one is to create the create task function. This is actually what's going to be implemented as a code by the agents. On the source file, we have got the service, so it's going to create the task. So that's going to be, the API is going to be the post with the post endpoint. We have got the components for the front end, and the integration is going to be there. So all these are going to be implemented using based on the tasks that we have mentioned here. So these are what's going to be implemented next. So based on this tasks, I was able to create this project. So this task management application, it's a basic one. So we have been working on this a lot. So let me show you what it looks like. So I think you can see what it looks like. Here comes the product. So as based on the following spec-driven developments spec kit, I was able to create this task manager. So this is how we are going to use the spec-driven development. If we are not going to use this spec-driven development, then the LLM will give us lots of answers. If we say build me a task manager app, if I say build me a task manager app, then it will give me a lot of things. It's not going to be architecturized. It's not going to be principle-wise. It's not going to be engineerized. So we have to have the spec-driven development for what we are going to achieve. So the real intent and the real product needs to be clearly put on the intent part. So based on the intent we have got, which is the specification we have put, we are managed to build this task manager. The next part we are going to see for today is the MCP server. So let's see the MCP in practice. So before we see that, let's discuss what MCP actually is, why we also need MCPs. So MCP stands for the Model Context Protocol. It's one way of communication we use for the agents. Since the agents are going to communicate with the external parts, the external systems, they actually don't directly communicate. They need to have a protocol to communicate. In order to understand with each other, they need to have this thing. So therefore, we are going to
Okay, so Johannes, I think you had a question, right?
Yes, like before we move on to MCP, I'm just curious about like there is this platform called Lovable, which allows non-coders to view websites and stuff like that. And once I learned about Git, like it's a different development, I'm just curious if someone could give us some insights, like if you guys know Lovable, could you please give us some insights how it works and the stuff like that, how they define the specs once the user writes what they want, what in their mind. The non-technical user tried that, and the app builds it, the agent builds it. So I just wanted to ask that.
Okay, so Johannes, Lovable is a different platform. Like you have a different platform. It's not like something you access with the ID. So I don't think it's like directly related to what's being discussed right now. But I'm not sure even like how the GitHub, if they do support, like Lovable does support the GitHub stack. I'm not sure about that. So what we are doing is we are working on our own ID, which is probably either VS Code or any of the forks of it, and it's different from Laravel. So I think it's beyond the scope of like this tutorial. Yes, Yosif?
Okay.
Okay, I have one question. Could you show us how you use the git stack commands to generate the files, the MD files, to understand more about how we use the git spec?
Okay, so the first thing that I have done while working on this project was initializing the git spec kit. So I did that using the git spec kit from the GitHub. You will get that from the GitHub. So let me show you.
Okay. To add on that, yeah, I set up the git spec, but yeah, in the chat prompt, we use the commands like specify or plan or task. So
Yes.
how do we use for the
Okay.
data wrap?
Okay, so let me show you how I use that. So you see the dot specify file here, right?
Yeah.
So it's already generated by the git spec kit. I used the command using the UV package manager. I installed just like what the git on the GitHub, how the git spec kit is being initialized. I think you have done that on X0 as well. So I just used that command. Then it gave me this folder, the dot specify folder. So on that dot specify folder was the memory, which the constitution is being put. So the only thing I have done is I came here and I constitutionalize my project. So before I start all these things, I have told you what my intention was. My intention was to create a task manager application. So I first started from my intention, then since the intent is the truth. So in order for the agents to work on that, the first thing that we have to do, we said constitution matters most because it controls the behavior. So I come here and I actually not wrote, but I generated the constitution using AI agents. So I told what I actually want to do, what my intention is, what I want, what it actually needs to contain as well. I want the task manager to contain what? I want it to create tasks, to update tasks, to delete tasks, and also to view tasks. Give me a basic CRUD application. So while I was working on that, I updated this constitution using the agents. So the agent gave me what I actually want. So the constitutionalizing part was done on that as well. Then the next one is based on this constitution. I think you can see the constitution, right?
Yes.
Yes, based on this constitution, since I mentioned everything that what I want, the boundary, it's not going to pass out of this. The LLM, when it reasons, it's not going to be out of this. It's going to play around on this area. So based on this constitution, I also generate what is going to be what I actually want, the intent which I previously mentioned. Like create me a task. I want to view the tasks that I've created. I want to update a task. This is what the agents are going to give me, the code after all. So this is the intention, the core of the source of the truth. So it's also generated one. So it's but this spec file is given with the git spec kit already. The git spec kit already, it gives me this format. So on that part, I will generate these things. So the tasks are generated as well. I mean the specs are generated as well. So based on the specs, I also generated the plans. The plans are generated using the spec I have shown you earlier. So I also did that using the agent. Then after that, the tasks are the ones that are going to come after the plan. So after I finish generating the plan, I used the tasks as well to generate. I used the agents to generate the tasks as well. So I use this part. Then here comes the outcome. So as I told you, my intention was to create task manager application. I try to explain that here. So based on that, when I implement the project, it actually used the plan, because the plan is the one that told us how to implement all these things. So using TypeScript, for example, let's see the technical context. It will not play, it will play around here. It won't apply anything else out of the TypeScript or the Next.js that is mentioned here on the language in the primary dependency part. So it will use this part. It's going to be web application. So the memory is going to be in memory. The storage is going to be in memory. So since it's a very simple one, this is how I wanted to implement the application. Then the project structure is going to look like this. Here it looks like this as well. So this is the plan actually. So based on the plan, the tasks are generated. So based on the generated tasks, I commanded the agent to implement that one. So after I give that in, it gave me this application. Is that clear?
Yeah, it's clear. I understand that. If you could, how how do you command the agent? That was my question. Maybe it's in the anti-gravity chart.
Yes.
You write the prompt. Is
Okay.
that the way? Yeah, on the chart, how do you?
So you want the chart history?
Yeah, kind
How
of. I saw on the Git spec GitHub they use in the chat they use like specific commands, like there are specified dot plan kind of. When we use the backslash the there are how do I say, there are some tools or there are some functions to use like to specify or kind of thing. And I tried that way on
so
the review.
I think you're seeing the git spec GitHub file as well, right?
Yeah, like
Yes.
this.
Yes. So you first use this
Yeah.
to install that git spec kit.
Yeah.
Then you initialize it using one of the LLMs, like it's using Cloud here. I use Copilot. The AI I used was Copilot. Then I checked the status, so it gave me all the what actually was supposed to be installed together. So after that, as I told you, it gave me this folder structure. That's the first thing I have done is that. So dot specify is given, and then in that was the memory, which contains the constitution. Then there was a spec folder which actually was populated while I was working here. While I was generating based on the constitution, while I was generating the functional requirements, the spec, which is the spec, then the plan, these were generated as well here using the agent on the anti-gravity.
Okay.
Did I
Okay.
answer your question?
I understand.
Okay. If you have got any question, please. Okay, Hermes, I think you have got a question, right? Hermes?
Can you hear me now?
Yeah, I can hear.
Okay. So yeah, my question is about after implementing a feature based on the specifications we give it, if we are not, if we didn't like the outcome or the output, what is the ideal way to go on about fixing that? I mean, should we redefine the specifications or just manually edit the specification documents?
No, what actually, that's a good question actually, because while I was working on this project, the task plan I had was this one. So while working on this, there was an issue, a code error, that needs to be solved. So there is on runtime, and let me show you on the constitution. So I do have what is going to be checked is we do have validation. So we have got runtime and build time. On the runtime, we have got Zorin TypeScript on the build time. So there was an error while I was working on this one. So I actually used this agent to solve the to debug as well. I have not come here and manually manually updated anything. So since it's going to since traceability is also one of the things that we want to make sure is kept as well, right? While working on codes, since when things are changed, they need to be logged or they need to be audited. So the next thing that will happen was after I've got the correct one, it gives me the updated one. So I think, can you see the updated one? So I do have a task.
Yeah.
I do have a task. Then when it works with the tasks, the first tasks that I had from the plan, it had got some errors. So it checked that, logged that, and gave me another one using the plan. So the first thing is the plan. Whatsoever is being changed in the plan is going to be changed in the tasks. So it will not just come and change the tasks directly, but it will check the plan. As we said, spec-driven development. First, check on the specification. So it checked on the specification, then it updated the tasks here. So it gave me the updated one here. So it's no longer using this one, but it's using this one, the updated one. So based on the updated task, it implemented the code, then it built using the npm. Since it's another application, it used the npm, then it built the application, then it worked. So first it got an error.
Okay.
So you are not going to manually fix things, but it's going to be checked by since it's constitutionalized, as I told you, there's this thing needs to be kept. So based on that, when things are changed, they are going to be looked as well. So you'll have a versioning as well.
Okay.
Is that clear?
Yeah, it's clear.
So next question, I think, Johannes. Johannes, do you have a question?
Yes. Another one. So, like, we can add the GitHub spec kit on already existing code base. Let's say the code base is a huge one, a production level code base. Like, what would be, like, how are we going to utilize it? Apparently, for this one, it's just you're building from scratch. What will,
Yes.
like, the workflow, or like, how would we utilize it in that case? Do you have any experience with
Um,
that?
okay, if I'm not mistaken, let me try to paraphrase what you have said. You're saying that there was a huge code base which was already been built, and you want to make it as a spec-driven development. You want to make it to follow this spec-driven development methodology.
Yes, I want to include this
That's the
methodology.
question.
Yes.
Okay. I'm not sure. I have not done that yet. But one thing that I have.
Let me just add on here. So, say you have a project that is already like initiated, and you don't have GitHub spec kit in that project. Now you want to introduce GitHub spec kit to it. So there is a way you can just add GitHub spec kit. You can initialize a GitHub spec kit directly in your existing project, and then say you want to introduce a new feature. Then when you, instead of like directly going to the chat base, the chatbot, and then like writing emojis, you use methodology specified by the GitHub spec kit. So it's still possible to actually use it on an existing project. Is it clear?
It's like I don't understand that. So like
Yeah.
we can add this on like in project. Like how about like the features are built? We don't need to build anything new. Maybe we're facing some issues, a bug somewhere, and we wanted to like we wanted the agent to understand the code base well and utilize those things or specs. Like, is there a way for us to include like those things that have already built in the specs so that the agent have full context of the code base?
Yes. Yes, like everything is, I mean, at the end of the day, you say it's a bug or a new feature addition, it all has to do with the code base, right? So if you are working on a code base, then you can describe your intent and using the GitHub spec kit. For example, like you said, you wanted to fix some bug, then you describe your intent that it's like, I need to fix this bug. So you will be creating the task, a plan, a task, and then finally once all of that is like you want it, you read it. Once it's created, you have to read it and it makes sense. Then if it does make sense, then you implement it. So the agent will then go ahead and implement what's written on the task. So I don't think it really does matter as long as you are working on the code base and you can just you can describe your intent.
Okay, yeah, go. I think you have raised your hands.
Yes, can you hear me?
Yes, I can hear.
Thank you for giving me this chance. Can you go to the VS Code, please, once?
Okay.
You told us the steps you took, and at first you initialized GitHub spec kit, and then you set the rules in the constitution .md file and the specs folder. You initialized the tasks intent you generated the intent using the AI, right?
Yes, I gave the what I actually want to work on. So it's formalized it like this. So first I checked on AI agent. I want this task manager application to look like this.
Okay. I have understood the steps you took, but at last, what command did you give to the ID AI in order to generate the whole project?
Okay, so since we're working on a anti-gravity, there it gets an agent, right? We're working it together here. So the last command I gave it was let's implement it now.
Okay.
So then it analyzed my whole code base, then checked on the tasks that were driven from the plan. So then it implemented the project.
Okay, thank you. I have understood it.
Okay. So let's continue to the next part. So let's see what MCPs are. So this MCP servers, we actually have raised this point, this concept on week 0 as well. We have tried to connect to the 10x analytics MCP server, right? So let's see the core part of what MCP actually is. It stands for Model Context Protocol, as I said earlier. So agents are going to talk now. So when they talk, they need to have a protocol. They need to follow some protocol. So this is a universal protocol for agents to connect to any other tools, not only the agents, but to any other external system. So if they have to refer to any other external system, they don't just go and access everything. For example, we don't want LLMs to just go and access an organizational SQL data or organizational database. We don't want them to do that, right? We want them to have some sort of protocol, to follow some protocol. So that's what MCP helps us to achieve. So it's a universal protocol, as you can see here. It says USB-C. This means it's for the AI. It's a universal protocol. So the other thing is when you use one of the LLMs, you have to have one kind of implementation for one and another for the other. So it needs a standard format to be followed. So this works for all. So it can connect to for all agents to connect universally. We need this MCP servers. So MCP, we need to this protocol. So using this, AI models can securely connect to external tools, data sources, applications. So we don't actually need to have any other implementation for ChatGPT or for Gemini, or there needs to be no specific one. So since we have this protocol, we can use this for all. So that's why we say this is a universal protocol. So using this MCP, we can integrate to different parts. We can access databases. So the agents, they don't need to directly connect to any of the data sources we do have. Based on the MCP servers, they will be served, then they will access that. We call APIs. We use external tools as well to refer. So we use these MCP servers to do that. So why this MCP matters? Because each AI tool needs custom integration before using MCP, as I told you, and because of that, there needs to be a different implementation for different. There needs to be customization for implementation. So it's already solved that problem. It's made the format standard. It standardized the format, so the models can discover and use them dynamically as well. And it's also easier to orchestrate AI agents for communication. So before that, this was not the case before MCP. So now we can use this for the AI agents to orchestrate as well. So there are three things that needs to be considered while talking about MCP. So what are these three things? The three primitives that needs to be raised are resources, prompts, and tools. So what are resources? Resources are the things that we are going to refer. So it may be the database record, it may be files or documents, or it may be also a log or API responses. These are the things that we are going to refer, or the resources that we are going to utilize. So these are actually the contexts that the MCP server is going to use to work on the next part. So based on the resources, based on one of the resources we have, then there is going to be a prompts. So the prompts are there will be an instruction, there will be a template. So that template is going to be referred by prompts. We use prompts in order to call to trigger the actions or the tools we have on the next part, which is we will see one implementation as well. But so let's go deep into the tools so that it makes sense when we use the prompts. So the tools are the functions that are going to be executed that perform actions, or what actually we want to serve, what we are going to serve. So this is going to be the output of what's going to be served. So these things are going to be referred using the prompts we are going to have. So there is going to be a template, then it's based on that we use prompts to refer to these tools. So, and the tools get the information from the resources. So I think it will be clear if I can show you one of the implementations we have done here. So I try to make one MCP server. So that's a simple one. It just, what it actually does is it searches a repo, GitHub repo. That's what it actually does. So let me show you how it works. So here it is. So this is the tool. One of the tools that we have on this MCP server is to search repositories. Just search repositories. What the agents are going to use to do is to perform a search action. So whenever I write here to search some repository, then it will search, since I have connected with the this server. Then the other one is the prompt. So this prompt is, as I have told you earlier, it has got a template. So that's going to be referred as using these prompts. Probably when you connect to the 10x the 10x server, you have used logger. Let me show you one of 10x. So we have used three tools, right? List manage servers, log passage time trigger, and log performance outlier trigger. So we have called these three tools. So just like that, the GitHub server we have worked on has got one tool, which is search repos. So this is how actually the MCP server works. So based on that, this is implemented using JS. It's implemented using JS, and based on that, we have got another one, which is a prompt. So we don't what it actually needs to work is to provide a 3 bullet point technical summary for the readmes of repos. This is what we want. So in order to do that, we just use the following, just like this: analyze, repo. Then we will give the repo so that it will check the README file and put the summary of the README using 3 bullet points. This is what it's going to do. The analyze repo prompt is going to do. So let's go back to the slide. So here we do have in our GitHub MCP server, we do have one of the functions we do have search repos, and one prompt we do have is analyze repo. So that's going to refer what? The Git. So here our resource is going to be Git. So we'll connect it with Git so that it will refer to Git. So when the agent asks those tools or those prompts, it will refer to Git. So Based on that, this server, there's this thing called transport. So it needs to connect with the extension to the anti-gravity or to VS Code or to cursor, right? So in order to do that, we do have, so how are they going to be connected with the outside or the MCP servers? So for the time being, we are going to connect that using the STDIO, which is, it's actually the MCP server is actually running in my PC. It's in local. So locally, it's running on local machine. So it's called STDIO. So it's in this terminal. But while you guys were connecting when you're working on Wix0, you use the HTTP, right? So which means it's served using the HTTP protocol. This MCP server is going to be accessed using the STD protocol. So with that being said, okay, we have worked with the MCP server, then it's going to be connected with the agents here, so that the agents are going to access external resources using the MCP servers. But when working on the MCP servers, we want to test them. We don't just want to work on the MCP servers and directly connect with the agents, since we don't know what's going to happen. So in order to do that, there's something called MCP inspector. Sorry, before talking about the MCP inspector, let's check the architecture. Here's the architecture. The architecture looks like we do have hosts, which basically are our environments, development environments. The cursor, cloud, it may be cloud desktop or the base code or custom application also, or anti-gravity. And the clients, the client part is the one that's going to send request for the service, which is the MCP server we're going to serve. So this is the client, and the server is the one that exposes the resources, the tools and the prompts, which we were talking about. We said we do have tools, we do have resources, we do have prompts. So that's going to be served by the server. So it is the one that connects us with the external system. Based on that, our MCP server is going to be, as you can see, it's implemented. Then we want to check it. Is that working or not? We just don't want to connect it directly to the agent before checking or testing if it's working or not. So there we use one thing which is called MCP inspector. We have MCP inspector so that it will inspect and check if it's actually giving what it actually needs to give. So for us, we have got a tool search repo, and analyze repo is our prompt. So how it's going to work, let me show you how the inspector works. I use this command. It's this project is built using the node, so you'll get this together. So based on that, I will run. It will build from the build. It's built already. This MCP server is, I have done it. So and it's built. So it will refer to the build one. So then when I run this, it will give me. It will redirect me to the inspector. So it redirected me to the inspector. So now we are going to inspect the tool and the prompts that we have. So as I told you earlier, we do have different types of connection. So now it's locally. The MCP server is running locally, so we are on the STDIO. But there are also other ways of transportation. So we have the streamable HTTP and SSE. So I think you guys have worked on the 10x analytics MCP server. When you connect, use the HTTP one. So I think it's clear here. So then the command is not, and the argument, I'll show you guys what it actually means here. So this is going to be the reference. When it runs the MCP server, this is going to be the reference. This is what is going to be run. Then if there is any environment variable we want to add, we will add it here. For example, you may need to add a GitHub token, probably. So if that's the case, then you will add it here as an environment variable. So let's try to connect the MCP server. So it's connecting. So our MCP server is connecting. So we do have tabs here, resources. We do have, what are the resources? We don't have, for the time being, there's nothing we do have for reference. We do have prompts, we do have tools. So for prompts, we do have one prompt, what we have done on our MCP server, which is analyze repo. And there's another tool. We have the tool search repos. So we'll test these two things. We do have these two things, so we'll test them. So for the prompts, we do have analyze repo. So we will put a repo here. Then let's check. For example, this is GitHub SpecKit repo. So let's give it here the repo, and we'll see what it will, the prompt will give us. So it gave us a message. So let's see the content. The content says, so the content shows text, and the text says, please use the GitHub file resource to read the README and give us a 3 bullet point technical summary of the README file. So since this is what we want the prompt to answer, this is how we could MCP server to answer. You can see it here. It's a template to summarize a repository. So since we're on inspection mode, it's not going to give us what we the real repo summary, but this is what we want for the message to be answered. So it gave us this one. So this is how we check if our MCP servers are actually, this is how we inspect them. So let's see the one of the tools. We have got search repos. So let's search a repo. Let's search SpecKit here. So when we run the tool, it gave us, it searched and gave us SpecKit, SpecKit CN and SpecKitty. So these are the ones that it got from checking on the Git. So this is how we inspect MCP servers before connecting them to actual agents. Since we don't want the actual agents to refer to the MCP server without any testing, this is how we inspect them. So based on that, the inspector will do some of the things that we want to check on. So it inspects the schemas, manual tool testing, and resource fetching. And as you have seen earlier, we can also inspect the tools in the prompts that we have been working on the MCP servers. Then we can connect it to the live agents after we check if it's actually working right. So thank you for your time. And if you do have any question on MCP server, please, we can discuss on that. Is there any question on MCP server, please? Nahum, okay, we'll make the recording available. It's being recorded, so we'll make the recording available. Any question, please? On the topic we have discussed today, is that clear?
Okay, I think you can end it.
Okay.